Welcome, everyone, to this Strategic Explainer. Think of this session today as your championship final. You're walking into that exam hall, you sit down, the invigilator says you can begin, and you have exactly 90 minutes to glory. What we are going through today is your ultimate, bulletproof game plan for absolute exam victory. We are tackling the Cambridge 0606 additional mathematics syllabus today, and specifically, we're taking on a topic that literally strikes fear into the hearts of so many students. Permutations versus combinations. Now, to really understand what's at stake here, I want you to imagine a real Cambridge past paper question. We're going to look at it through the eyes of two archetypal students tackling this exact problem. First up, we have Alex. Now, Alex works hard. Alex has memorized every single mathematical fact, every formula in the textbook. But when you look at Alex's exam paper, his answer block is just completely overloaded with raw numbers, scattered factorials all over the margins, and absolutely zero analysis of the actual real-world scenario the question presented. It's just a data dump. Then, on the other hand, we have Sam. Sam actually understands the underlying math really well, but constantly rushes. The numbers are technically there on the page, but Sam completely missed the all-important command word requirements. Sam ended up calculating a permutation, arranging items in a specific order, when a combination was clearly what was needed, because the question heavily implied that the order did not matter at all. If you could see their papers right now, you just see the examiner's red pen marks bleeding all over their flawed answers. They dropped so many easy marks. Well, today, our mission is to completely transform those red marks into green check marks. We're going to build a strategy so solid that you'll never make Alex or Sam's mistakes again. I want you to really absorb this direct quote from a Cambridge senior examiner. They wrote, "Permutations versus combinations is one of the most misunderstood areas in additional mathematics. Let's fix that right now." This isn't just me making an observation. This is coming straight from the top, directly from the people who hold the red pens and grade your actual papers. The stakes here are incredibly high because the specific topic isn't just about plugging random numbers into your calculator and hitting the NPR or NCR buttons. Any student can push a button. This topic is really about logical translation. It's about reading a real-world scenario. Maybe it's about forming a committee made up of teachers and students with specific gender constraints. Or maybe it's about arranging a set of distinct books on a library shelf where certain books absolutely refuse to be placed next to each other. You have to translate that everyday English into precise, correct mathematical syntax. When students fail here, when they lose those crucial marks that separate a B from an A star, it is almost never because they can't do the basic arithmetic. It's because they fundamentally misinterpret the relationships hidden inside the data. They see a selection, but calculate an arrangement. They see mutually exclusive events, but decide to multiply instead of add. That specific failure in translation is the most common point of failure globally, and it is exactly what we are going to completely eliminate from your toolkit by the end of this session. All right, let's look at our briefing agenda for today. First, we'll unpack the core exam challenge. Second, we're going to break down the procedural framework. Third, we'll reveal a massive secret weapon, the method mark strategy. And finally, we will expose the critical examiner traps so you can avoid them. Let's get right into it. Section 1, the core exam challenge, theoretical foundations and cognitive domains. Because honestly, before you can beat the exam, you have to truly understand the rules of the game the examiners are playing. The hierarchy of assessment objectives reveals exactly how Cambridge is grading your thought process. First up is knowledge and understanding. That's your baseline. Do you know what a factorial is? Do you know the core formulas for permutations and combinations? But that alone won't get you the top grades. Second is application. Can you apply that formula to a relatively straightforward word problem? But here, right here, is where the battle is actually won or lost. Analysis. The 066 syllabus clearly states that they prioritize analytical depth over superficial breadth. Remember our friend Alex from the introduction? Alex failed because he relied solely on that first step, knowledge and superficial application. He threw math facts at the paper without any analytical depth. Sam failed because his application was rushed, entirely skipping the analysis of the actual command words. The examiners desperately want to see you pause and analyze. The constraints. For example, what if you have to create a 4-digit code, but the constraint says the number must be even and it must be greater than 3,000? You can't just mash numbers together. You have to analyze. Okay, for it to be even, it must end in 0, 2, 4, 6, or 8. For it to be greater than 3,000, the first digit must be 3, 4, 5, 6, 7, 8, or 9. You have to structure your answer to prove you understand this. We actually use a framework for this, adapted for mathematics, called the Peel framework. Point, evidence, explanation, link. Top students structure their math answers logically, almost like a short essay of numbers. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. So what does true mastery look like? The syllabus defines it as connected conceptual understanding, transferable to unfamiliar contexts. Let me translate that for you. In your actual exam, you are going to open that booklet and see a scenario you have never, ever seen before in your life. It won't be the exact committee problem you practiced in class. It might be about selecting a highly secure computer password with bizarre character restrictions, or scheduling a complex roster for airline pilots across different time zones. Top-performing students don't freeze up or panic when they see an unfamiliar context. They don't just guess. Instead, they rely on a structured approach to break the weird scenario down into familiar mathematical pieces. They transfer their logical reasoning. They calmly ask themselves the golden question. Does order matter here? Yes, because a password of ABC is fundamentally different from a password of CBA. Therefore, I am dealing with a permutation, not a combination. This level of calm, connected, systematic thinking is the exact cognitive domain the examiners are testing. It's what separates the truly elite candidates from the rest of the pack. Section 2, the procedural framework. Now we're moving from the high-level theory directly into the technical, actionable methodology you need to deploy the exact second the clock starts ticking in the exam hall. This right here is your ultimate 5-step procedural framework. This is how we take Alex and Sam's flawed, messy answers and transform them step by step, turning those red marks into green check marks. Step 1. Deconstruct the question. You have to actively hunt for command words. Are they asking you to show that something equals a specific number or to find the total number of ways? Step 2. Extract relevant data. Physically pull the numbers out of the paragraph. What's the total pool of items? How many items do you need to select? What are the specific annoying conditions the examiner threw in? Step 3. Select the analytical framework. This is the big pivot point. Permutation or combination? Does the sequence matter, or is it just a messy group selection? Step 4. Execute with clear notation. This is where that Peel framework we talked about earlier comes to life. Your point is the mathematical method you're stating you will use. Your evidence is the extracted data. Your explanation is your clear working out step by step on the page, writing out the factorial expansions before you just blindly write the final answer. Step 5. Present with correct terminology. Please, never just leave a floating, unexplained number at the bottom of the page. State clearly what that number represents in the specific context of the exam question. Let's distill that 5-step process into what we call the mathematics success blueprint. It's an unstoppable problem-solving cycle. Deconstruct, solve, evaluate. When we sit down with students like Alex and Sam to rewrite their answers live, this is the cycle we force them into. First, they deconstruct, pulling the given information apart and breaking it into logical, bite-sized steps. Then they solve systematically, showing every single piece of working. But the most critical, and honestly the most frequently skipped step, is evaluate. You must always check your final answer for real-world reasonableness. If a question asks for the number of ways to simply arrange 5 people in a straight line for a photograph, and your calculator somehow spits out an answer of 3.6 million, you need to pause and evaluate that. Does that make any logical sense? Absolutely not. 5 factorial is just 120. Evaluating your answer against the physical, real-world constraints of the problem is your ultimate bulletproof safety net against those devastating, careless calculator errors that cost so many students a whole grade boundary. Section 3. The Method Mark Strategy. This is all about how marks are awarded for your process, not just your final answer. And hey, stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's unlock the secret of the method mark. If you're someone who feels a lot of anxiety during math exams, truly understanding the method mark strategy is a total game changer. The method mark strategy is the Cambridge examiner's strict practice of awarding you points for demonstrating the correct mathematical process and systematic reasoning, even if your final arithmetic gets a little messed up. Let's do a quick interactive workshop challenge right now. Imagine I put a complex data table on the screen in front of you. It shows available digits and letters for creating a specialized vehicle license plate. You have 60 seconds on the clock. Go. Your job in that 60 seconds is to scan that data and extract the core trend. How many vowels are available? How many consonants? How many odd numbers? If you extract this data accurately under pressure, and you write down the correct structural equation on your paper, let's say you show that you are choosing 2 letters from a pool of 5 and multiplying that by choosing 3 numbers from a pool of 9, you have just secured the method marks. Even if, heaven forbid, your finger slips on your calculator during the last 5 seconds of the exam and you write down the wrong final digit, you have still proven your procedural skills. The examiners actually want to reward you for your beautiful logic, but they can literally only do that if you physically show them that logic on the page. Let's look at another challenge. We call this Find the Flaw. I'm going to show you a text comparison, and I want you to spot why one of these loses marks instantly. A generic answer says, use NCR, 10C3 times 5C2. That's it, just that floating equation. This is a vague application of formulas, and it absolutely bleeds marks. If the final calculation is wrong, the examiner is forced to give you a 0 because they have no earthly idea why you chose those specific numbers. You haven't justified anything. Now look at the context-specific answer. This is the gold standard we train students to write. It says, Step 1, choosing 3 senior students from a total pool of 10. Since order does not matter for a committee, we use a combination, 10C3. Step 2, choosing 2 junior students from a pool of 5, 5C2. Therefore, total possible combinations equals 10C3 multiplied by 5C2. Do you see the massive difference there? The context-specific answer explicitly links every single mathematical step directly back to the given scenario. It's a narrative. When you write like this, the red marks vanish and turn into green check marks because the examiner can see the exact perfect architecture of your thought process. Let's level up to Challenge 3, Speed Writing. You've got 30 seconds on the clock. How do you write a perfect Peel paragraph when you are faced with high-level evaluative thinking demands? Top-scoring candidates don't just blindly calculate, they evaluate constantly. They question given assumptions. For instance, if a question says a team of 5 is to be chosen from 4 boys and 6 girls, a weaker student assumes any random mix of 5 people is totally fine. But a top candidate acts like a detective. They spot the limitation hidden in the next sentence. Wait, the conditions state there must be a majority of girls on this team. They identify that severe limitation immediately. Then they consider alternative interpretations. What does majority of girls actually mean in a team of 5? It could mean exactly 3 girls and 2 boys, or it could mean exactly 4 girls and 1 boy, or it could even mean 5 girls and 0 boys. They break the problem down into these 3 mutually exclusive cases. They calculate the combinations for each case individually, and then they add those results together, justifying their decisions with evidence all the way down the page. That is how you dominate the 0606 paper. Section 4, Critical Examiner Traps. All right, we are officially entering the danger zone. Everything we've discussed so far is about building up your perfect answer. But now, we need to talk about defense. We need to look at the specific, nasty pitfalls that destroy grades. These aren't just guesses or rumors. These are direct, harsh insights mined straight from the Cambridge Principal Examiner reports. And I can tell you there are exactly 3 major mistakes, 3 consistent, devastating errors that sabotage students' grades year after year in this specific topic. When the senior examiners sit down to moderate the papers globally, these 3 exact things make them sigh in absolute frustration. So, the question is, are you making them? Let's find out right now. Here they are, the top 3 examiner warnings. Warning number 1, answers are too vague. As we proved in the Find the Flaw challenge, just scribbling numbers with 0 logical connectors is a one-way ticket to losing all your method marks. The examiners are begging for specific details of your selection or arrangement process. Tell them what you are doing. Warning number 2, students forget to check format and presentation. This sounds basic, but it's deadly. We are talking about sloppy handwriting under time pressure, where your permutation P suddenly looks exactly like a combination C, or failing to use your brackets properly, which leads to your calculator processing mathematical nonsense. Presentation is communication. Warning number 3, answers are not specific to the context given. Let's see the question asks about arranging colored beads on a circular string to make a bracelet. Your answer has to reflect the physical 3D reality of that string. You have to realize that turning the bracelet over in your hand means the clockwise and counterclockwise arrangements are actually identical, so you have to divide your final factorial answer by 2. If you just do standard straight-line math and ignore the physical context of the bracelet, you've fallen right into the trap. To completely counter those traps, you have to force yourself to adhere to strict conventions. Think of this slide right here as your ultimate cheat sheet recap graphic. Picture a progress bar on your screen filling all the way up to 100% mark potential.
A perfect, top-tier exam paper uses proper headings. For example, explicitly writing out Case 1, 3 girls, 2 boys, and underlining it so the examiner knows exactly what that specific block of math relates to. It uses correct, formal terminology, it uses appropriate mathematical formats, and above all else, it features clear annotation. Your exam paper shouldn't look like a chaotic scratch pad. It should read like a short, highly logical story. If you want the final system, it's 3 rules. Rule 1, command word decoding. Know exactly what they're asking. Rule 2, Peel framework application. Structure your math like an argument. Rule 3, time management matrix. Don't rush like Sam and don't overwrite like Alex. Pace yourself so you have time to evaluate.
Let's really cement this whole strategy with one final ultimate examiner alert. The principal examiner states, the classic mistake is providing generic answers not specific to the question context. Always link every point to the given scenario. That is the golden rule of permutations and combinations. And you know, students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. So here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. You have the tools now, you just need to commit to the process. As we wrap up this session, I want to leave you with a final, provocative question to ask yourself the next time you sit down with a practice paper. Are your mathematical conclusions truly evidence-based and context-specific? Don't just ask yourself if you memorized the right formula. Ask yourself if you have translated the story correctly. Have you respected every single physical constraint in the problem? Have you shown the examiner every step of your brilliant logical mind on the page? If you can confidently answer yes to those questions, you are incredibly well on your way to mastering the 0606 exam. Keep practicing, keep analyzing. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.